Hello students, today we will be going through the problems on three-phase circuits. So let's first see what are the different types of formulas in this. So you already know for a star connection, EL will be equal to root 3 EAP, line current will be equal to the phase current, and power will be given as root 3 EL IL cos phi. For delta, what you need to do is delta will be exactly opposite to that of the star connection. So you can see here line voltage is equal to the phase voltage, line current is equal to root 3 IP. Power will remain the same for both the star and the delta. So P is equal to root 3 EL IL cos phi. So let us go to the first problem. A balanced star connected load is supplied from a balanced three-phase 400 volt 50 Hz system. The current in each phase is 30 amps and lags 30 degree behind the phase voltage. Find the total power, phase voltage and draw the phasor diagram. So we'll see what we have got here. So balanced star connected load. So they have given it as a star connection. Next, it is a 400 volt 50 Hz system. Now what is this 400 volt? Is that a line voltage or a phase voltage? Now, whatever they give you in the question is always a line voltage. If it's a phase voltage, they will specify it. So EL is equal to 400 volt. Frequency is given 50 Hz system. Current in each phase is 30 amps. So they have given you the phase current I phase IP equal to 30 amps and lags 30 degree behind the phase voltage. So you can see here the phase is nothing but 30 degree. They have given it is lagging behind the phase voltage. So next, they have asked you to find out the total power, phase voltage and draw the phasor diagram. Now, you already know that power is given by root 3 EL IL cos phi. Now for a star connected system, we have IL is equal to IP. So that means IP is given as 30 amps. So that means the line current will also be equal to 30 amps. Next, EL is given. Phi is given, you can substitute in cos. So cos phi. So if you substitute this everything, you will get the power. So this is the answer for your first question. Your second question is finding out what is the phase voltage. Now what is the equation for the phase voltage in terms of for your star connection? Now for your star connection you already know EL is equal to root 3 EP. So they have already given you the line voltage which is equal to 400 volt in your question. Substitute in this equation, you will get the phase voltage which is equal to 231 volts. Your next question was to draw the phasor diagram. Now how do you draw this phasor diagram? Now while explaining the phasor diagrams for the star connection, delta connection and also the 2 wattmeters, it was clearly said that for the first thing that you need to do is always draw the references. Now in this case, you need to first draw the references ER, EY and EB. So this will be your first step, drawing the phasor diagrams ER, EY and EB. Once you draw ER, EY, EB, the next thing that you can do is draw the negative of this, that is minus ER, minus EY and minus EB. So next, once you finish drawing this, next thing what you can do is draw ERY, EYB and EBR. So these are the three steps to draw the voltages. So what we'll do is see here. First you can draw this ER, EY and EB. So you already know that all these phase voltages ER, EY and EB will be 120 degree away from each other. So I have drawn it accordingly. ER, EY, EB all 120 degree displaced from each other. Your next step is drawing the negative of it. So minus ER, minus EY, minus EB. So ER is here. So minus ER will come somewhere here, exactly opposite to it. Minus EY will come exactly opposite to EY. So you can see it is drawn here. And minus EB will exactly be opposite to EB. So this will be minus EB. Third step is to draw ERY, EYB and EBR. Now you already know ERY is nothing but ER minus EY. So it comes between ER and minus EY. This is what we have drawn ERY. Similarly EYB, which comes between EY minus EY and minus EB. So you can see here EYB. Next is EBR, which comes between EB and minus ER. So you can see it here. So once you draw this, your next step is to draw the currents. So in your question it was clearly given that the current is lagging the phase voltage. Now which is your phase voltage? You can see here the phase voltage is nothing but EB, ER and EY. So they have clearly said that the current lags the voltage. That means after the current starts exactly 30 degree after the voltage starts exactly 30 degree after the voltage, you will have to draw your current. So IR lagging behind the voltage by 30 degree, EY lagging behind the voltage by 30 degree, IB lagging behind the voltage by 30 degree. So this is about your IR, IY and IB currents. So this is what you mean by current lagging the phase voltage. So this is your first question. Let's go to the second question. A balanced three-phase star-connected load of 150 kilowatt takes a leading current of 100 amps with line voltage of 1100 volt 50 Hz. Find the circuit constants of the load per phase. So a balanced three-phase star-connected load of 150 kilowatt. So what is this 150 kilowatt? This is nothing but the power. So P is equal to 150 kilowatt takes a leading current. So here the current is leading. So current is nothing but 100 amps. So IL is equal to 100 amps with line voltage of 1100 volt. So EL is equal to 1100 volts 50 Hz. Find the circuit constants of the load per phase. So what you need to do is you need to find out the circuit constants. Now what do you mean by the circuit constants? So now you clearly know the load can be of different types. That means you can have a load of RL or RC. So now you need to find out what is the combination of the load here. Is it a RC combination of the load or is it a RL combination of the load? Now first we will see which is the load. Now in your problem it is clearly given that it is a leading current of 100 amps. Now you have already studied that if it is a RC combination, then the current will be leading the voltage. If it is an RL combination, then the current will be lagging the voltage. So since they have clearly given you it is leading, that means the circuit constant has to be RC. So what do you have to find out is you need to find out R and you need to find out C. Suppose they give you a lagging current, that means clearly the circuit constants will be nothing but R and L. So this is how you find out which is the type of the load. So next, let's see what we have to find out. Now EL is already given. What about E phase? So you need to find out the E phase first. For star connection, you know this is your formula, EL is equal to root 3 EP. Substitute in this, get the phase voltage. Next, IL is already given, EL is already found out, phi you don't know, but power is already given. So from this equation you can clearly find out what is the power factor cos phi. Now, once you find out cos phi, we can go to find out the next things. Now, let me first find out what is the impedance ZP. So you already know ZP is equal to EP into IP. So you might have already seen this equation, V is equal to I into Z in your previous modules. Here we have simply written this V as E, so that is the only difference. So from that itself, ZP is equal to EP by IP. Find out what is the impedance. Once you find out the impedance, you can use this equation. RP is equal to ZP into cos phi. This is nothing but cos phi is equal to R by Z. You might have already studied this equation. So I have just written this so that you don't get confused with what is this, from where this equation has come. So cos phi is equal to R by Z. From this equation, you have got this. Substitute impedance, substitute cos phi, you will get your resistance. So once you get the resistance, let me find out what is the reactance. Now this formula, this is from this equation. Z is equal to root of R square plus X square. So this X square can be a inductive reactance or a capacitive reactance. So since it is a capacitive reactance here, let me write it as Xc square. So from this equation, you have got this. Xc is equal to root of Zp square minus Rp square. Substitute and you will get this answer for the reactance. Once you get the reactance, then you can find out what is the capacitance value. So you already know Xc is equal to 1 by omega C equal to 1 by 2 pi Fc. We have already studied this. Substitute in this equation, get the answer for capacitor. So this is how you find out the circuit constants. Let's go to the third question. Calculate the current flowing into each terminal and in each phase of the winding of a three-phase delta-connected induction motor developing an output of 250 HP at 2300 volt between the terminals at a power factor of 0.75 and efficiency of 85%. So, what do you have to find out here? First, we'll check that. So, here it is given that it is an induction motor which has an output of 250 HP. So here the output is given in terms of horsepower. At 2300 volt, this is nothing but the line current EL between the terminals at a power factor. So power factor cos phi is given 0.75. Efficiency is given 85%. Now you need to find out what is the current flowing into each terminal. So what do you mean by current flowing into each terminal? It is nothing but the line current. Now, before proceeding to the solution, let us first see what is this horsepower. So, 1 horsepower is equal to 0.7355 kilowatt. You need to remember this so that I can convert this 250 HP or 250 horsepower into the watts. So, remember this, 1 horsepower is equal to 0.7355 kilowatts. Next. What I'll do is, I'll first find out what is the input to the motor. So you already know input to the motor is given by this formula, input equal to output by efficiency. So output was already given it as 250 HP. Now I want the answer in watts. So what I'll do is I'll convert this HP into watts. So you already know 1 HP is equal to 0.7355 kilowatts. That means 250 HP will be nothing but 250 into 0.7355 kilowatts So substitute this in output in kilowatts divided by efficiency, you will get the answer in kilowatts, that is the input. So this input is nothing but the power. So power is clearly 216.3235 kilowatts. So now you have power P, voltage EL was already given, cos phi you have already was already given in the problem. The only thing that you don't know is the line current. So they have asked you in the problem clearly that you need to find out what is the current in the each terminal, that is nothing but the line current. So IL is equal to P divided by root 3 EL cos phi, so 72.4026 amperes. Now for delta connection, phase current is different than the line current. So find out what is the phase current, substitute in this equation, you will get the phase current. Next is the fourth question. So a balanced three-phase star connected load draws power from a 440 volt supply. The two wattmeters connected indicate W1 equal to 4.2 kilowatt and W2 equal to 0.8 kilowatt. Calculate the power factor and current in the circuit. So they have given you the power readings of two wattmeters W1 and W2, and they have given you the supply. Now what you need to find out is the total power P, power factor that is cos phi, and the current in the circuit, so that is current IL. Now power you already know. Now they have told you that there are two wattmeters. The power of these two wattmeters will give you the total power. So in order to find out the total power, you have to just add up the readings of W1 and W2. That will give you the total power. Now why I have done this is because you already know in a three-phase circuit, two wattmeters are sufficient to measure the total power. So we have already studied about this. So because of that, adding the readings of the two wattmeters will give you the total power in the circuit. Next is the power factor. So how can you find out the power factor? Now, you already know there is an equation tan phi equal to root 3 W1 minus 2 divided by W1 plus W2. So I have already got the readings of W1 and W2. Substitute in this, you will get what is tan phi. Take the inverse of it and find out what is phi. You will get 49.6 degrees. Substitute this phi in cos, you will get the power factor. So this is how you find out the power factor. Next you need to find out what is the current. Now how can you find out the current? Now you already know that we have got an equation P is equal to root 3 EL IL cos phi. Now power we have already found out in the previous slide. EL is already given. IL is the one which you need to find out. Cos phi we have found out already in the previous step. So you can directly find out what is IL from this power equation. So that is how you are going to substitute and find out the answer. Next, let us go to the fifth question. Three similar resistors are connected in star across a 400 volt three-phase supply. The line current is 10 amps. Calculate the value of each resistor, the line voltage required to give the same line current if the resistors are connected in delta. So what they have said is, three similar resistors are present and which are connected in star. So they have given you line current is 10 amps, line voltage is 400 volts. Now you have to calculate what is the value of each resistor first. Then we will go to the next question. So first you need to find out what is the value of each resistor. Then you need to find out what is the line voltage required if the same line current is produced when the resistors are connected in delta. So first question, we have to find out what is the resistors. How can I find out? Now you know already for a star connection IL is equal to IP. That means you can directly find out what is the phase current. Next, line current was given, but phase current was, the line voltage was given, phase voltage was not given. From this equation I can directly find out what is the phase voltage for a star connection. So once I have the phase voltage, once I have the current, I can directly find out the resistor. So R, and this is nothing but V is equal to I into R. So V I have denoted as EP here, I and RP. So using this I have found out what is the resistor. Your second question was, you need to find out what is the phase voltage if the same line current is flowing through the circuit when the circuit is in delta connection. So line current is same, so that means IL is equal to 10 amps. But now here in the delta connection, phase current and line current are different. That means you will have to calculate the phase current. So phase current IP is equal to IL by root 3. Substitute, calculate. So once you calculate that, you can then calculate what is the phase voltage. EP. EP is equal to IP into RP. Substitute, get the phase voltage. Now for your delta connection, you already know phase voltage is equal to the line voltage. So directly you can find out what is the line voltage. Next is the sixth question. A balanced delta connected load of 8 plus J6 ohms per phase is supplied from a 3-phase 440 volt source. Find the line current, power factor, power per phase and total power. So what they have done is they have given you the load 8 plus J6 ohm per phase from a 3-phase 440 volt source. 440 volt is nothing but the line voltage. You have to find out line current line current IL, power factor cos phi, power per phase and the total power. So before proceeding to the actual solution, what we'll do is first we'll find out what is the magnitude of the impedance ZP. So you already know Z is equal to root of R square plus X square. So using this equation, I have substituted root of 8 square plus 6 square and I have got the answer as 10 ohms. Now you already know EP is equal to IP into ZP. So from this formula, what I can do is I can directly find out the phase current IP. So because a phase voltage is already given and your impedance is already found out. Next. IL is equal to root 3 IP for your delta connection. You already know IL is equal to root 3 IP. That means phase voltage is found out. That means now you can substitute in this equation. In this equation, find out what is the line current. Next, power factor. Now power factor you already know cos phi is equal to R by Z. So substitute in that, find out what is the power factor. Next they have asked you is power per phase. Now, whenever you were finding out the total power, that was for 3 phases. But now they have asked you for power per phase. That means I just have to neglect that 3. Instead, find out just for per phase or for a single phase. So I'm just going to write EP, IP, cos phi. So this will be power per phase. So if you have to find out total power for 3 phases, that means just add 3 because it is a 3 phase. So 3 EP, IP, cos phi. Substitute, get the answer. Next question. A 440 volt 3-phase AC motor has an output of 80 HP and operates at a power factor of 0.866 with an efficiency of 90%. Calculate the current in each phase of the motor if the motor is delta connected, the readings of the 2 watt meters connected in the lines to measure the input power. So what they have given is the line voltage 440 volt. They have given the output in the horsepower 80 HP. Power factor they have given 0.866. Efficiency is given as 90%. You have to find out what is the current in each phase of the motor if the motor is delta connected. And the readings of the 2 watt meters, that is nothing but W1 and W2. So next. First what I'll do is I will connect this output which is given in the horsepower into kilowatts. Now you already know 1 horsepower is equal to 0.7355 kilowatts. Let me convert this into the kilowatt. So what I'll do is 80 HP into 0.7355 kilowatt will give me the output in the kilowatts. Next, I need to find out what is the input. Now you already know from your previous problems that input is given by output by efficiency. Output is already found out previously in here in kilowatts. Substitute that. Kilo efficiency is already given in your problems. Substitute, get what is the input to the motor. So this is nothing but the input to the motor or the power. Next, cos phi is given. I will find out what is phi from this. Next, I have to find out what is the line current. So what I'll do is, I'll substitute in the power equation. Now, total power is nothing but the input that you have found out previously. So that is nothing but 65.3778 into 10 to the power 3 kilowatt. Root 3 into EL is already given in your question. IL is the one which you need to find out. Cos phi was already given. Substitute, get IL. Next, they have asked you what is current in each phase of the motor if the motor is delta connected. Now for your delta connection, you already know current, that is the phase current and the line current, both are different. So you have already found out line current. Substituting in the equation for delta connection of line current, that is IL is equal to root 3 IP, you can immediately find out what is the phase current. Next is, they have asked you to find out what is the reading of the 2-watt meter, that is W1 and W2. So I'm going to assume it is a lagging power factor. Now, cos phi was already given 0.866. What I'll do is, I'll find out what is phi from that, which I have already done in the previous slide. So finding out from that, substitute in the equation. So tan 30 degree equal to root 3 W1 minus W2 divided by W1 plus W2. Now what is this W1 plus W2? So this is already we have already found out this in the previous. This was nothing but the input to the motor. Input to the motor is nothing but the power. So 65.3778 into 10 to the power 3. So substitute and find out what is this W1 minus W2. Now you found out what is W1 minus W2 here. W1 plus W2 you already know, that is nothing but the total power. Substitute in your calculators, find out what is the individual W1, what is individual W2. You will get the readings for the 2 watt meters. So thank you.